Welcome back to our video series on the Play framework using Scala. We continue talking about Scala.js here, and we want to look at two other ways that you might interact with it inside of a web page in the standard way. Now, we are going to see how this integrates with our larger project that included Play, but right now I'm just looking at how the Scala.js produces JavaScript that you can use on any web page anywhere. I should also note that while I am talking about Scala.js here, this is not the only option. I do think there is a huge benefit in using a statically typed language that transpiles to JavaScript so that you don't have to write JavaScript. I've gone through in the last video and pointed out a number of the advantages there. Scala.js is not the only tool that will do that, but I do think there is an advantage to having that. I also think there's an advantage to using the same language on the client and the server, and that's what we're going to do in some subsequent videos. Kotlin has the ability to compile actually to all three of the platforms that were mentioned for Scala. The existence of TypeScript as a language was basically to try to make a JavaScript that had types and didn't suck so much, that would tell you about your errors early on. Personally, I think that TypeScript, because it preserved so much backward compatibility with JavaScript, doesn't have as much of an advantage as, say, the Scala.js or Kotlin that compiles down to JavaScript. But it is very popular because it doesn't force you to make all of your changes. As a result, it's not quite so beneficial, in my opinion, unless you have a large code base that you're already working with. Anyway, so what we want to do now is we were able to change what was in an existing element. We were able to add new elements. What about interacting? There are times when you want to have something in your website that you actually that calls code in JavaScript. So let's do a little example of this. What if I had a button in here? Okay, and our button has an on click, and we want it to do some type of a code. So do click stuff. Okay, and this is JavaScript. Okay, now when Scala.js compiles, let's make sure we have some text there. When Scala.js compiles, you saw what it looked like in one of the previous videos. It does a lot of name mangling. The JavaScript that gets spit out is really not for human consumption. So how would we make sure that this do click stuff was visible here when we have code that's inside of here? And this is actually a standard problem that people run into, and so Scala.js has a solution to it. It's actually this import up here, the JS Export top level. So there's a number of annotations that exist in Scala.js that deal with exporting and how things are visible from the Scala.js out in the actual JavaScript that it produces. So we need to add a method that has the ability, and I could call it this, but just calling this here isn't going to be sufficient. For one thing, this is buried inside of an object. The Scala.js compiler is going to do interesting things with the name. And just to, going back to my JavaScript, print line, button click. We'll just start off with the simplest thing that we could do. In order to make it so that this is actually seen from the outside, indeed, if I just compiled that, let's go ahead and let's verify. So there's my button. Okay, I don't like my button being that far down. Come back to the index. I want that. That's interesting. The button is above the canvas. No idea why the browser decided to show it. Okay, putting a line break in there gets it so it's above. When I click this now, I get an error because just saying do click stuff as a method inside of here isn't sufficient. And saying hello.doClick stuff wouldn't work either. Okay, Scala.js has to do some interesting things with the naming to make everything happy, because JavaScript's naming can the way it works, you don't have the package arrangement and whatnot. It's not the same as the Java and Scala one. This is where that annotation of JS export top level, we get to specify the name that we want this to be exported to. So now when I save that and I refresh the page, now we get button clicked. So if there's something that you want to interact with and you need to know a JavaScript name for it, you can use this annotation. There are also annotations for just JS export that you might need to include sometimes to say that certain element of code needs to be maintained. Mainly if it is being called from directly from the HTML or from other JavaScript code. Scala.js basically is going to start with this main, and it will find everything that is called from this main. But if something isn't being called from this main, if it isn't reachable from here, it could optimize it away. And so the JS export is also a way of saying that this is code that needs to be maintained. Don't optimize this out, because we're actually using it. It's just we're using it from stuff that's outside of the Scala.js. So now we're able to do that click. This is how we can get code that is inside of our HTML or inside of other JavaScript that we might have to access things that are inside of our Scala.js. The last thing I want to look at before we move on is I put this canvas in here. Okay, and I feel like it might be nice to do something with the canvas in there. And now it turns out in order to deal with a canvas, you often have to do things that really aren't quite ideal, at least not for standard Scala code. So I have that canvas. And I want to draw things to it. So def draw to canvas. And so I have this import here for the DOM HTML so that I can get things like canvas in here. This is actually just going to draw. Once again, it'll return unit. It is the side effects that we care about here. And if you remember how to do canvasy stuff from JavaScript, you'll remember that there's something called a context on there, and you have to pass the context the type of context you want, because it's possible to have 2D context, 3D context. For whatever reason, they decided to do this. But this is a very dynamic thing to do. The get context, you don't actually know what type you're getting back. And in JavaScript, in raw JavaScript, that's not a problem, right? Because you don't have types for any objects. You just get an object and you start calling stuff on it, and you cross your fingers and hope it works. And Scala says no to that. Right now, I couldn't do anything with this context. I couldn't draw anything to this context. I have to know that this is a particular type. And the thing that we don't do much in regular Scala code is called the as instance of. Okay. The as instance of does exactly what the name says. It will take our type and basically say this is definitely something else. Okay, so instead of having the dynamic type, we're going to say, no, we know this is some particular other type. Now, there are some safeties in here in the sense that there are some type conversions that you know certainly can't work. Okay, the type conversions, if you were to say take a one of these nodes and try to treat it as like an integer. Well, that's clearly not going to work because it's not a subtype. So you can't just convert anything to anything in the Scala language. Now, of course, we're in Scala.js, which is going to compile to JavaScript. Because JavaScript is a lot more free, it is possible that you might be able to have broader things. For example, dynamic can be converted to basically anything because we don't know what it is. In order to have the helpful error messages, we want to forcefully say, you know what, this object that we got back here happens to be a canvas rendering context. Okay, so I'm doing an explicit typecast there to really to tell Scala.js this is the type. And that way I can, for example, fill a rectangle at location 100, 100 that is 200 in width and 150 in height. I'm not doing much drawing here, but showing that now because this knows that this is a canvas rendering context, we can call a method everything type checks and is happy. Now we need to call this with the canvas that we had. The canvas has an ID of canvas because I was really creative here. And so in our main, what we can do is we can call, actually, let's see, draw to canvas. And we need to get element by ID of canvas. And this won't compile. And it shouldn't compile, because we said down here we're passing in a canvas, and up here, when you do a get element by ID, you get an element. Okay, the name says exactly what you're getting. And we know that we have a more specific type of element. We know that when we go for a canvas, we're actually going to get an HTML canvas. Here again, how do we make the Scala happy with this? We're going to have to force it to have the right type. Okay, so these are just things that they pop up a lot more in Scala.js than they would in standard Scala, mainly when interacting with these DOM elements, because we're doing things like passing in strings, and we know those strings relate to particular types, and we have to tell the language that that is the case. And there we go. I have a rectangle. Okay, so we now know how to use in the Scala.js language, kind of use the standard JavaScript stuff to interact with the DOM, canvases, adding elements, modifying elements, and even make calls from HTML and regular JavaScript into the Scala.js code. That was a good primer for us. We'll come back next time and we'll see how to integrate this with our larger project that included all of our play code and stuff like that.